In mathematics, the word quadratic links to square. Square is obviously a quad. And when we're dealing with these number patterns, they're going to have a general formula that looks very similar to one you either have already learned or are going to learn for the quadratic function, the parabola. Okay, so with these, there is a formula that is y equals ax squared plus, you might have had ax squared plus q so far, but we have one that adds a middle term that looks like that. So the formula we're going to use for a quadratic number pattern is going to be Tn is going to be an squared plus bn plus c. And as you can probably predict, we have to find numbers for a and b and c. The first step with finding the formula for a quadratic pattern is to establish that it is actually quadratic. So you'll remember when you did linear ones, you had to check the difference between the first and second term and the second and third and so on, and you had to check that this difference was the same. What we're going to find now is that it's not the same, but when we do it on the next line, it will be the same. So here we have a difference of 7, here we have a difference of 9, and there we've got 11. What you'll notice with these is that your line of first differences looks like a linear number pattern, because here we now have a difference of 2 and a difference of 2. So here we have a constant second difference. And that's how you know that it's a quadratic pattern. So you do need to test for that if you aren't told that it's quadratic. To find the formula, there are some pretty cool tricks with these sequences, but they do require some memorization. Okay, the first thing is we're going to find A, B, and C. The first thing is to start at the bottom. You have to have written this out like this to be able to work with the way that the formulas can be completed. So the first thing is that 2a, because we're finding A, B, and C, 2a equals the second difference. Okay, so then you would say 2a equals 2, you solve for a, you get out a as an answer, which we'll do in a moment. The next thing is that 3a plus b equals your first difference. Not any of the others, because they're different to each other, but the first one. And lastly, a plus b plus c equals your first term. You need to memorize these little formulas to be able to do anything from now onwards. So if 2a equals 2, dividing both sides by 2, a is going to equal 1. Then we use that in the next bit. 3a plus b equals 7. But we know what a is, so we sub it in. 3 times 1 plus b equals 7. Okay, so 3 plus b equals 7, so b must be equal to 4. Now I have the answer for a and b, so the last one's going to be easy. A plus b plus c equals 6. So a is 1, b is 4, and c we don't know. So that is 5 plus c equals 6. Therefore c must equal 1. You've now found the values for a and b and c, so you put it together in the formula. Your final answer then for finding the general term is Tn equals 1n squared plus 4n plus 1. Okay, so besides finding the general term, there's normally two kinds of questions that are straightforward that come after this. The first one is to find t something. So they're going to ask you for a value. And it's really critical that you understand when they're asking for a value. So they're going to say, for example, find T100. So they're telling you the position and they want the value. In the second kind of question we're going to look at, they give you the value and they want the position. And switching those up gives you 0 marks, and getting them correct gives you 100% of the marks. Okay, so T100 means that every time you see an N, you are subbing in 100. So that is 100 squared. Please, when you substitute, use brackets, because if there was a negative number before the N squared, for example, if the A value was negative 2 N squared, that negative 2 would be outside of what you're squaring, and it's important to make sure that you know what you're squaring and what you're not squaring. So I'm only squaring the N value, not the coefficient as well. Okay, plus 4 times the 100 plus 1. Try to do these in your head for a homework task, but when it comes down to something that is time sensitive, like something for marks, then you rather use a calculator and make sure that you type correctly, and you'll save yourself quite a bit of time and anxiety. Okay, so if I type that into calculator, I'm going to get out 10401, and I found that the 100th term equals that. The other question type is where you are given the value and they ask you for the position. This is where you have to find N. The value, we were finding Tn, or we were finding the actual value of a position. So we were given a number for N, but we had to find what Tn would be when we knew what N was. The next one's the opposite way around. We have to find what N would be when we are given Tn. These questions tend to have a phrasing commonality. They'll say which term is, for example, 118. There are other ways of asking this question. This one is the most common, and you can pretty much know you're finding N when they give you a number that is in the actual sequence. Then what they're asking for is the only other thing they can ask for, which is N. So if I say which term is that, I go back to my formula and I write that down. And I know that they're telling me that the whole term has a value of 118. So that gets subbed into my Tn so that I can find the N. So I have my Tn equals the formula that I worked out. And then I sub that in for the Tn. Okay, so now it's looking a lot like a quadratic equation, which is exactly what it is. I'm going to continue solving up here. So I need to get this to be a 0, so I'm going to move it across. So I'm going to have 0 equals n squared plus 4n, and then when I move that across it's negative, so it's negative 117. Right, so that does factorize in quite a pretty way. And if you are really good at factorizing and you're quite good at multiplication, times tables, etc., then you can factorize that into 2 brackets. If you can't, or if you just want to save time, you can use the quadratic formula. So a reminder then of that formula, and you do need to know this off by heart, and you can't afford to make any mistakes when you plug it into your calculator or when you are writing out the formula. So that's a negative. And that, whatever the b value is, it all gets squared. If you try this with me now and you come out with an answer that's different to mine, it's probably a typing issue, and you need to resolve that by checking that you've typed it in correctly. Okay, so typing that into the calculator, I'm getting out 2 answers, which I must do because it's quadratic. Quadratic means square, square means I get out 2 answers. So I'm going to get out that n equals 9 or n equals negative 13. And here's a little bit of logic. In a pattern, in a number pattern, when we go T1, T2, T3, T4, T5, at no moment do we ever have T negative 13. We start on 1. We start with natural numbers. So this one can't work, and all we need to do is strike through the equal sign. So what we do know is that it's the 9th term. That is our answer. This is a theoretical answer. It's a mathematically possible answer. if it wasn't for the fact that it is now actually a number pattern. So number patterns can't have ends that are negative or numbers that are not whole numbers. Okay, so that means that T9, that's the answer we got out, T9 is 118. And that's your answer for finding the position of a value that they gave you. This is an example that requires you to apply some of the previous steps to one where they don't give you the second term, but they do tell you that it's quadratic. Now sometimes you have to prove it's quadratic, in which case you write out the sequence, you do your calculations about your differences, and you prove that the second differences are constant. And once you've done that, you've proven it's quadratic. Here, they tell you it's quadratic, which means you know something else. So telling you that it's quadratic simply means that your second differences are all equal to each other. They are constant. So you know that even though you don't have that number, when we do these little calculations, when we get to the second differences, and we can get maybe one of them, we know they're all going to be the same. In this example, the negatives complicate things as well, which is why I've chosen it. You must remember that when you're calculating the differences, you're taking that one minus that one. Okay, so we don't know what x is, but we do know that the difference between x and negative 4 is x minus negative 4, right? Which is actually x plus 4. Okay. Then we've got x over here and negative 28. And we know that the difference between them is going to be negative 28 minus x. And this one we can actually get. The difference between negative 46 and negative 28 is going to be negative 46 minus negative 28. Okay, I'm just going to add an extra line where I clean up these numbers. Okay, so just keeping it simpler for myself, I know that these are my first differences. Now because I'm told it's quadratic, what I know is that the second differences will be the same. When I know things are the same, I can put an equal sign between them and solve. So what I know about this is that whatever that comes out to be with a whole bunch of x's is the same as that. So now, I know that negative 28 minus x minus that whole thing, I'm putting brackets because otherwise I'm going to get something wrong, that's going to be the same as this one here, which is negative 18 minus negative 28 minus x. This thing here equals that thing there. So I can set up an equation and solve it, because they told me it's quadratic, which means the second differences are constant. So setting up that equation here, I'm going to multiply things in. I'm going to multiply in that negative. And I'm going to multiply in that negative, which obviously changes those signs. Now I have a linear equation, and I'm solving for x. Collecting my like terms, I'm going to put my x's all on the left-hand side. I've got negative 1, and then that's going to be a negative when it moves as well. So on the left-hand side, I've got negative 3x. And on the right-hand side, I've got all of these numbers. Negative 18 plus 28 plus 4 plus 28. When I do that, I get 42. And then I'm just going to divide by negative 3 on both sides. And I'm going to have x equals negative 14. So now I've solved for x. Once I've got x, what I can do is I can go and put it into my sequence here. So I'm going to have negative 4, and then I'll just stick it in here. It's actually negative 14, and so on. And then from there, I can work out the first differences, because I've got actual numbers now. And I can work out the actual second difference. I can get the general term. I can find T100. I can find the position if they give me the term. All of the normal stuff now applies because I found x. Here's a question that asks you to apply things differently. They tell you the second term is 1, the third term is negative 6, and the fifth term is negative 14. But they don't give you the first term, in fact they ask for it, and you have to then calculate the second difference as well. What they have to do with these questions is tell you that it's quadratic, otherwise you can't work any more than that. Okay, now what we're going to try and do is reconstruct what we know and try to get it into the model that we already have, which is all the numbers, their first differences and their second differences. Okay, so I don't know what the first one is. So T1 is something. Let's call it X, because we're used to working with that. So let's say T1 is X, T2 is 1, T3 is negative 6. Okay, that's helpful because I can get a difference here. Okay, then there's the matter of T4. We can call that Y because we also don't know what it is. And we don't know its relationship to X, so we can't write it in terms of X either. And then we've got T5 is negative 14, and obviously it continues. Right, so our first differences, that'll be 1 minus X. Negative 6 minus 1 gives me negative 7. Y minus negative 6 gives me Y plus 6. I'm just cleaning it up as I'm going. And this one will be negative 14 minus Y. Arguably it gets even messier on the next round, but what's great about the second differences is that we know they're equal to each other. Okay, so here, this one is going to be negative 7 minus, and I'm putting brackets to make sure I don't make a mistake here. This one is going to be Y plus 6 minus negative 7. So that's going to be Y plus 13. For this one, I'm doing a little calculation on the side, just to show you how I final up with that answer. So I've got this one, subtract that one in brackets. So I'm going to have negative 14 minus Y minus Y minus 6. So I end up with negative 2Y minus 20. Okay, so this one is negative 2Y minus 20. Now, I've got an X here. I've got a Y there and a Y there. I know that all of these are equal to each other. But look here, this one's got a Y in it, and that one's got a Y in it. So, if I make these two equal to each other, I can solve for Y. Once I've got Y, I can get this one's actual answer and that one's. And then I can equate this guy to the ones that I've already worked out. Here goes. So negative 2Y minus 20 equals Y plus 13. Moving things around, I'm going to have negative 3Y here. And I'm going to have 13 plus 20 on the right hand side, so I'm going to have 33. And dividing through by the negative 3, what I learn then is that Y equals negative 11. Now I can figure out what that is. Right, so Y is negative 11. Negative 11 plus 13 gives me 2. Okay, I've just gotten the second difference. So the constant second difference is 2. I'm allowed to make that assumption because it told me it's quadratic, and I know that these guys are the second differences. Okay, so first bit of the problem solved. And now I need to use the fact that Y is 11 to get out my answer here. Okay, so I know that this over here equals the constant difference, which is 2. So I know that negative 7 minus 1 plus x, I'm just multiplying in there, that gives me 2. So collecting my like terms then, I've got x here by itself, and I'm going to have 2 plus 1 to give me 3 plus 7 to give me 10. So I've solved x and y, which by the way I created in the first place. They didn't put any x's and y's in the problem, and that's what makes this a little bit more tricky to do. Okay, now what we did is we put in some x and y's, and we used the first term as x. So we've actually solved all the problems because now we know that x is the number we gave, it was x, and its final answer is 10. So t1 equals 10, the constant difference equals 2, and we've solved the whole problem.